And I can go over this right here, draw an example of adjacent angles. And let me just show you right here. So draw an example of adjacent angles. And you guys know that adjacent angles are two angles that are next to each other, right? Share the same vertex and have a common side. Remember that? So that's an example of adjacent angles. Also, if you had something like this, angle 1 and 2 would be an example of adjacent angles because they have a common vertex and they share a common side. Okay, and they don't have any interior points in common. Okay, so we got that, Trey. So everybody know what adjacent angles are? Yeah. Anyway, I'm going to go do the other ones. So I'm going to go over these. Draw an example of vertical angles. You guys, when two lines intersect, the angles across from each other are called vertical angles. So angle 1 and angle 2. No, not 2. Angle 1 and angle what, you guys? 3. And angle 4 and angle 2. Okay? So those are the vertical angles. Draw an example of complementary angles. Anybody know this one? Okay, two angles that make 90 degrees. So if I have a right angle right here and I have this line going through it and this is a 35-degree angle, what would the other angle have to be be a complement to it? 55, right. Okay, so 55 degrees. So we have, those are two angles that add up to 90 degrees. What about supplementary angles? What are those? Two angles that add up to 180. So usually we have a straight line and have something going off of that. Let's say this one was 50 degrees. What would the other angle have to be a supplement? 130. Good. Okay. And draw an example of a linear pair of angles. Linear pair of angles is kind of like supplementary angles, aren't they? But not all supplementary angles are linear angles. If you have a straight line and you have anything coming off of that, angle 1 and angle 2 would be an example of linear angles. If you have two lines intersecting, like right up here on the vertical angles, 2 and 3 would be a pair of linear angles, right? 1 and 2 would be a pair of linear angles. 1 and 4 would be a pair, and 4 and 3 would be a pair. Okay, any questions on the bell work? All right, was that our second bell work on that? Or first one? Oh yeah, the first one, because we turned it in last time, didn't we? All right. Okay, I'm going to go over a couple questions on the homework assignment, and we're going to correct it, and then we'll review for the test. Okay. Any questions on the homework assignment? We'll go over 3 questions. 40. Okay. Find x so that A is parallel to B. So we have a pair of lines called A and B, and we want, they look parallel, right? And we have a transversal going through them. And we have that this angle is 80 degrees, and this angle is 3x plus 1 degrees, like that. Okay, and I have to find x so that line A and line B are parallel. Okay, we're mixing a little algebra right here into our geometry. So, okay, you got this one, right? But you got to know your geometry first. Okay? You got to know your geometry first. What do we know about those two angles, you guys? Okay, that's right. Because what do we call these? Do you guys remember what we call these kind of pair of angles? When you have a transversal and you have two lines like that? What do we call these? Consecutive interior angles. I know that's a hard one to remember. We call these consecutive interior angles. Consecutive interior angles. Okay, and like Isaac was saying, he knows what they do. They have to add up to 180. They have to be supplementary, right? So they have to be supplementary. Now he knows that it has to equal 100 because 100 plus 80 is 180, right? So what's an equation I can write, an algebraic equation I can write, and I can solve and find x so that those two add up to 180 so it makes the lines parallel? Three x plus 1. Yeah, and there's two ways we can write it. No, actually, equals 100 will work, but could we write 3x plus 1 plus 80 equals 180? Okay, because we know that this plus this adds up to 180, right? And that's what this is saying. We got the angle that's 3x plus 1 plus the angle that's 80, and they add up to 180. But if you minus 80 from both sides of this one, which equation do you get? You get the first equation we wrote, right? That one right there. So some of you guys are just jumping to that one, and that's fine. Okay, so let's solve this equation. 3x plus 1 equals 100. How do I solve that? Okay, minus 1 from both sides. I get 99. Then what? And I get what? 33. Now, if x is 33, then 3 times 33 is, plus 1 is 100. And so those two consecutive interior angles add up to 180, which means they're supplementary. Therefore, line A and line B are parallel, right? And so that answers our question. Any other questions on that one? Okay, I've got one more, or two more questions. 35 and 41. Okay. 35. Okay, one telephone company's charges are given by the equation y equals 0.4x plus 0.99, where y represents the total cost in dollars for a telephone call, and x represents the length of the call in minutes. Y represents the total cost in dollars for the telephone call, and x represents the length of the call in minutes. Okay. A says, make a table of values showing what a telephone call will cost after 0, 1, 2, 3, 4, or 5 minutes. Okay, here's my table of values. What am I going to put in for the x's right there, you guys? It tells you in the book. 0, 1, 2, 3, 4, 5. That's what it says, right? What does x represent again, you guys? X is the number of No, it says, let me read it to you again, where y represents the total cost in dollars for a telephone call, and x represents the length of the call in minutes. So x represents the minutes, right? So if you have 0 minutes, how much is it going to cost you to make this phone call? Actually, 99 cents. It means if you're on there between 0 and 1 minute, okay? And if you're between 0 and, or 1 and 2 minutes, it's going to cost you 0.4 times 1 plus 99 cents, right? Okay? And so forth. Yeah, this is number 35. Okay, so here we go. If I put 0 in, 0.4 times 0 plus 0.99 is going to cost you 99 cents, right? 0.4 times 1 is 0.4 plus 0.99 is going to cost you what? $1.39, $1.39, right? Think of that 0.4 as 40 cents. And then you got 99 cents. Okay, if I call for 2 minutes, 0.4 times 2 is 80 cents plus 99 cents is $1.79 for that call. For a 3-minute call, it's 3 times 0.4, right? Which is $1.20 plus 99 cents. So what's that going to be? $3.19. $2.19, sorry. What's 4 minutes going to cost you? $1.60 plus 99, $2.59. And 5 minutes is going to cost you how much? $2.99. 5 minutes. You know, that's back in the day when before cell phones. That's how, and they still charge like that. But how many of you guys ever use your landline to call long distance? You usually use what? Huh? I still have one. How many of you guys have a home phone still? Okay. The only reason I have a home phone is because I don't like people calling my cell phone that can get a hold of me. Yeah. Well, it is expensive. There are some things. The problem is if you ever have to call a bank or you need to make a secure phone call, cell phones can be tapped into and listened to, and there's people out there that's how they make their living. They're thieves. Huh? No, they don't know. They just are always listening to several different at a time, and then they listen to one, and that's how one way they commit fraud, identity fraud. Huh? But a landline, they can't do that. They can't tap into it that way. Yeah. So, all right. Why not? Are you saying Bailey isn't worth pinpointing out? Because I think she is. So, no. Okay. Actually, I think the government does do that sometime, but it's for a good reason, probably. It's because you are doing something illegal, right? Yeah. I think if they got caught doing that for a good reason, they'd get in a lot of trouble. Okay. Hey, I forgot. We're all online right here. We're still recording, so. Yeah, we just had that. So we're going to graph these on our table, on our graph here. 0, $1.99. So we're going to say this is 1, 2, 3, 4, 5, 6, 7, going across there. So each one, and then 2, 4, 6, 8, 10. Okay, 0, 99. 0, 99. So if you make a Colby right there, it's going to cost you 99 cents. 1, 139. Be about right in there. 2, $1.79, about right in there. 3, 219, about right there. 4, 259. 5, 299. By the way, what kind of graph is this making? It's making a line, and it's positive slope, right? A line that's a positive slope. Now it asks you, what is the slope of this line? What? Yeah, well, it's positive, but what is it? How do I find the slope, you guys? Sierra, do you know how to find slope? Okay, you can count the rise of one. The problem is on a graph like this where it's in decimals, it's hard to tell. I gave you a slope formula. What was it? M equals, Sierra, here's the slope formula. Write it down. Everybody who wasn't here last time, there's the slope formula. Okay, got it? All right, y2 minus y1. I can choose any point as y2 and any point as y1. Which one do you guys want to choose? 2 and what? Okay. Okay, let's do those two. I always like to choose the 0 one. So 179 minus 99 over 2 minus 0. What's $1.79 minus 99? Is that 80 cents? 0.80 over 2. And what's 0.8 divided by 2, you guys? It's 0.4, right? Okay, now, what does it represent? Guys, what does this 0.4 represent? The average what? No, you said it. What? The average rate at ranges. Because look, isn't that our slope right there, you guys? Remember we learned slope-intercept form last time? Yeah, that would have given you the answer right there. It raises 40 cents for every minute you call. So that's what it, yeah, the whole time right there. And then it asks you, what is the y-intercept of the line? What does it represent? Well, what's the y-intercept? How much does it cost even if you call for 1 second? What's your It represents the minimum phone call, right? 99 cents represents the minimum phone call, price of the phone call. And that's it. I do remember back in the day when they charged like this, and every once in a while they would have a special for like 2 hours where you could call for 5 cents or 10 cents a minute. So that's when you called people. It was neat. It really was back in the day. Because you got to call your relatives from long ways away for really cheap. Yeah. Okay. We didn't have that back then. You remember how it was my birthday yesterday. By the way, it was my birthday yesterday. I bought you guys some candy for my birthday. Yeah. It's in my cupboard. I'm going to get it out in a second. Okay. Okay. What is I would have forgot about it if you guys wouldn't have said that. But okay, is that it? 41. Halok used the design. I don't know. How do you say that? Haloki? Halok used the design shown below in a quilt she made for her grandmother. Name all the angles with Q as a vertex. Name all the angles with Q as a vertex. Well, you guys, on 41, there's several different answers. UQT, TQR, VQR, UQV, VQT, UQR. There's 6 of them. There's 4, there's 2 obtuse angles, 2 acute angles, and there's 2 linear angles. In other words, straight angles. UQR is an example of a straight angle. Okay? That answers that question. We're going to turn this assignment in. Ready for the test. Okay, review for test. This is the first question. I want you to draw a diagram with a transversal. Draw a diagram with a transversal. Yeah. Okay, here we go. Share your answer with everybody in group. Make sure you got the right answer. Hey, indicate which line is the transversal, guys. Which one's the transversal? Okay, person 2, show me what you have. Good. Show me when you got it. Okay, good. Which one's the transversal, though? You got to tell me which one. Yeah. Okay, good. 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 Which one's the transversal? Okay, well, they're all going straight. Huh? The vertical one. There you go. Hey, guys. A transversal. The transversal is the line. Hey, guys. The transversal is the line that intersects 2 other lines, okay? We usually, Bailey, we usually use them when we're talking about 2 parallel lines, and then the other line goes through them. That other line is called the transversal, okay? All right, second question. Second question. If you have this cube right here, this is called A, B, B, C, D, and E, F, G, and H. I want you to name a skew line to segment AD. A skew line to segment AD. Take a piece. You don't have to take that one, whatever one you want. You put that back in. Take a piece.
We should take like 4 pieces.
You got to share it with everybody.
Thank you.
You're welcome.
Why did you get us candy if it was your birthday?
It's a good question.
There's nothing good in there.
I've got others over there. We can get more out. No one's taking these red ones. They must not be very good. Oh, they are cinnamon?
Yeah. And the blue, the yellow, the orange.
Would you like to throw one?
Mm-hmm. You're welcome. Mm-hmm.
No, actually, can I change it?
Yes.
Oh,
I got more. Do you guys want something else?
sorry. Yes, please.
Both of you?
Yes, sir.
All right. I got caramels. Bailey, you want a caramel? She didn't get one. Sorry.
I'll take all the candy you don't want. All of it. You don't get the candy.
I don't want you to be that unhealthy. All right. Here we go. Spinning. Okay, person 4 if you got 4 people, person 3 if you got 3 people. Show me skew line to that. Okay, good. That one will work. Does that say GF? Is that what it says? Okay, that will work. AB. AB does not work. It actually intersects it. EC, we already said that one works, yeah? Okay, good. Wait, EF, EF, let me see. EF is actually parallel to AD. FG would work. FG and EH would work. Remember, if you guys extend these lines some forever, it's not parallel to it, and it wouldn't ever intersect it. Okay. Who else had an answer I didn't look at yet? EH will work. Okay. All right, next question. Whoops, I was recording all that. I didn't mean to. All right. Okay. Find the slope. Given 2 points, 2 comma 10 and -8 comma -3. Find the slope. Mm-hmm. Guys, just a favor, please put all the wrappers in the garbage so I don't have to go pick them up. Welcome. All right, spinning. Put your heads together. Make sure you got the same thing in all your group. Hmm? Oh, really? I've never had them. Okay. Person 3, whether you got 3 or 4 people. That's right. You got the sign wrong. It's supposed to be positive. Okay, but negative over negative makes it positive, right? That's not correct. Hey, who's 3 in that group? Jordan, that would be you. You got it? Come on. And, yeah, except for negative over negative makes it positive. Hey, look, you guys. Negative 3 minus 10 over negative 8 minus 2. Negative 3 subtract 10 is negative 13. Negative 8 minus 2 is negative 10. A negative divided by negative is a positive, so it's a positive 13 tenths. I could have also went like this, 10 minus a negative 3 over 2 minus a negative 8, and that gives you, remember, minusing a negative is adding, so that would have been 13 over 10. Any questions there? Okay. Next question. Going back to this one. Name all lines parallel to AD. Name all lines parallel to AD. Name all lines parallel to AD. There's 3 of them, in case you weren't sure. Okay. Share your answer with everybody in your group. Make sure you got the same thing.
I already got it right. Sorry.
Okay, person number 3. Show me what you have. Okay, that's right. That's right. That's right. That's right. That's right. Person 3. Okay, good. All right. Okay, next one. Next problem. Okay. Okay, there you go. Guys, hey, Seaver. Okay, measure angle 9 equals 115 degrees. Find measure of angle 6. Okay, Seaver. See ya. Yeah. Speak as one having experience. Do you have experience with this? Oh, really? Okay, here we go. Okay, person number 4 if there's 4 people. Person number 3 if there's 3 people. Okay, good, good, good. Hey. Okay, good. I didn't see anything from this group back here. There's 4. Person 4. Brainer. Right. Okay. Okay. All right. Guys, at 65 degrees. Look, I want you to understand this. Guys, if measure of angle 9 is equal to 115 degrees, okay, then every other angle on there is either going to be 115 or the supplement of 115. What's the supplement of 115? 65. Like, this one's 115. This one and this one correspond, so that one's 115. And these two are vertical, so that one's 115, right? Which means all the others have got to be supplements to them. And okay, these two correspond. These two are linear pairs, so that one's 65. This one's 65. This one's 65. And this one's 65. Do you understand that? Now, here's the problem. On the test, it's going to ask you questions like this. Are you ready, Jody? You guys, some of you guys are out of order. I'm going to put you back in the other seat if you don't listen when I'm talking up here. You got to listen when I'm talking up here, okay? Okay. Okay. On this one right here, okay, let's say, I want you guys to tell me, what do we call a pair of angles like 8 and 9? What is it called? What pair of angles is 8 and 9 called? Okay, just write it down. What do you call 8 and 9? What kind of pair? What's the name of the pair of angles 8 and 9? It should be in your notes if you don't remember. Or you can look it up in your book. Chris should be thinking about this, pondering it, finding it, not blowing smoke. Not blowing powder. Okay, spinning. Person 1, show me what you have. Good. No, 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 no. One person had it. They're alternate interior angles, you guys. Look. Alternate interior. What's the other pair of alternate? Listen. What's the other pair of alternate interior angles, you guys? 7 and 10 are the other pair of alternate interior angles. Next question. What is a pair of corresponding angles up here? What is a pair of corresponding angles up here? Just name me one pair. There's more than one pair. You get that? I'm throwing it in the garbage. Corresponding angles. What is a pair of corresponding angles? Okay, write it down quickly. What is a pair of corresponding angles? I'll give you a hint. At an intersection, it's 2 different intersections. They're in the same place, but in different intersections. So corresponding angles are in the same place. They correspond. They mean they line up. They're the same place. If you were to put one intersection over the other, they'd be in the same spot. Okay, here we go. Person 2 in each group, show me what you have. Okay, 5 and 9 will work. 7 and 11 will work. Okay, yeah, you got all of them. 10 and 12, no, 10 and 12 is not one. Okay, 6 and 10 is one. 6 and 10 is one, yeah. You guys, look, corresponding angles. So you know, 6 and 10, 8 and 12, 5 and 9, 7 and 11. Okay? All right, next one. Name a pair of alternate exterior angles. 5 and 12, 6 and 11 are a pair of alternate exterior angles. Okay, last one on this one. Name me a pair of consecutive interior angles. A pair of consecutive interior angles. Wait, I got to say that again. 7 and 9 and 8 and 10 are a pair of consecutive interior angles. Okay, next slide right here. Okay, you guys, what does that symbol stand for? What does that symbol stand for? Just write it down really quickly. Spinning. Person 4. If you got 4 people, person 3. If you got 3 people, show me what you got. Okay, good. 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 Okay, good. Stands for congruent, doesn't it? Okay? All right. In this picture of these 2 straight lines, kind of like they're straight, 2 straight lines, what are, I want you to name 2 pair of congruent angles. 2 pairs of congruent angles. Name 2 pairs of congruent angles. Tell me the slope and y-intercept of this equation. The slope and y-intercept of this equation. The slope and y-intercept of this equation. Tell me the slope and y-intercept of this one. I keep forgetting to turn this thing off and on. Okay, to do this problem, you guys, I'm going to minus 4x because I got to get in the form of y equals mx plus b. I'm left with negative 6y on this side and negative 4x plus 12 on the other. I divide by negative 6. Those cancel out, and I get y equals negative 4 over negative 6. Is that correct? X plus a negative 2. By the way, guys, negative 4 over a negative makes a positive, and 4/6 reduces to 2/3. So it's a positive 2/3 x minus 2. Because I got confused. I looked at so many wrong answers. I couldn't remember which one was the right answer. Okay? Yeah. Probably not in yours. I'm saying you don't care enough to learn it so you can see if you need it. I got to tell you a story about my brother-in-law. Okay? My brother-in-law, what grade are you in? Okay. When he was in junior, he was in geometry too. He went to Pineview High School. Here's your assignment. Write this down first before you go sit down. You guys, Chapter 4 review. Page. Starts on page 180. And I want you to do the evens. 2 through 42. Evens. 2 through 42. Okay? If you know how to do all these problems, and if you want some extra practice, do the odd ones. Do the odd ones. I'm not going to give you extra credit, but in a way you will get extra credit because you will do better on the test, and the test is where most of your grade comes from. Okay? Study for the test, you guys. If you want to go back and look at this video, this might help you remember some of the stuff we learned today. Okay?